right, so today we're doing limits of accuracy for measuring instruments. All right, so what that means is that the limits of accuracy equal plus or minus half of the smallest unit. Because our measurements are normally in decibels, we're saying plus or minus 0.5 of the smallest unit. Okay, so what does that mean? Well, it means that if you're looking at something like this ruler, and I'm measuring something, and it says here that my ruler is in centimetres, and I'm measuring something, and I might be measuring it to be, it might come up to where I've put that black mark there. Now, sorry, which way am I going? All right, so when you see that black mark, if I said give it to me to the nearest centimetre, you would say that that's 65 centimetres. Okay? If you have a look at the rest of it, we have 65, which is here. Then we have 70 further over. But these big lines here are actually, which way am I going? It's hard when I'm on the video here. Okay, with these ones here, that's 66, the bigger one, 67, 68, 69, and then we hit 70. These little marks are halves, right? So the little mark here would be 65.5 centimetres. Then we hit the 66 centimetres. So if we were trying to measure it as close as we could to the closest line that we can see, we would say that where I've put the black mark is closest to 65 centimetres. Right? However, if I put it somewhere else and put it here, measured something and it came up to there, that black mark is closest to the next little line, which is 65.5 centimetres. So we would say that that was 65.5. So whatever it's closest to. So we make a judgment when we're trying to read a measurement of where it's closest to. So in other words, if I'm looking at something, I'll get to these examples in a minute, I'll show you a little bit more. So we have an error, okay? So sometimes in the Olympics, you'll have a look and you'll go, well, they said that so-and-so got third place and got the bronze medal, but I can see that the person who got fourth has the exact same time. So they might have run the 100 metres in 10.09. All right, that happened with our Australian sprinter. He ran in 10.09 and so did another man in the same race. They both had 10.09, but they gave third place to the Australian. All right, because they could see with the naked eye that he actually crossed further on. Okay, he crossed the line quicker, so he was third, even though the times are the same. So our measuring instruments can't go any more than 2 decimal places when we're measuring sprint times. All right, so that's what happens here. It's the same sort of thing. So we have a limits of accuracy which you need to learn. It's plus or minus a half or 0.5 times the smallest unit of the measurement you're using on the scale. The lower limit and the upper limit. In the other video I'm going to get you to watch, they call them lower bound and upper bound. The Americans call them that. But it's the same thing, lower limit and upper limit. So the lower limit will be the measurement that you said minus half or 0.5 times the smallest unit. Okay, that's the lower limit of what the actual measurement could be. The upper limit is the measurement plus the 0.5 times the smallest unit. Okay, so looking at a few examples over here, for each measuring instrument we're going to state the size of one unit on the scale and the limits of accuracy. So if you have a look at this scale here, it tells you it's in millimetres. Make sure you look at that as well. And it's giving you a 60 and a 70. Now if you count this quickly, you will see that there are 9 little marks in between the 60 and the 70. But remember, when we're doing this, we're counting gaps. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 spacings there between the 60 and the 70. So we can see that this one here, that next line, would be 61. And then 62, 63, 64, all the way up to 69, 70. All right, so 1 unit on our scale is between the 60 and the 61. So it's 1. The gap between them is 1 millimetre. So that's what 1 unit on our scale looks like, 1 millimetre. So to get the limits of accuracy, you're going to do plus or minus 0.5 times that smallest unit that we have on our scale, which is 1 millimetre. So all you have to do is work out 0.5 times 1, which you can do that in your head, can't you? So we're going to have plus or minus 0.5 millimetres. Now let's have a look at the next one. We're looking at a clock over here. So if we think about what the clock is doing, I've left some of these things off, sorry, I'll just put them back in. All right, and it goes like that all the way around the clock. Okay, so we're looking at the smallest gap from here to here. And we've only got 2 hands on this clock. We've got the hour hand, the short one, and the minute hand, the longer one. There is no second hand on it. So the minute hand is the one that moves quicker, okay? And every time it goes from one of these to the next, it's going through 1 minute. Right, so that spacing there is 1 minute. So that is the smallest unit that we have on our clock. So to get the limits of accuracy, we're going to do plus or minus 0.5 times 1 minute, because that's our smallest unit on our clock. And again, you're just working this out. It's not always going to be this easy. And don't forget, you have to give your units. You will get these wrong if the units are missing. All right, because what's to say it's not plus or minus 0.5 hours? Okay, so make sure you get the units on this. All right, now in C, if we have a look at this, it says it's in millilitres. And if we have a look, we've got a 50 here. That would be a 0. They don't always put the 0 on. That would be a 0. And here's your 100. So if we just look just between the 50 and the 100, we have 1, 2, 3, 4, 5 spaces. So to get from 50 to 100 in 5 jumps, what is each one of those lines? They have to be 10, right? So we'd be getting, that next one would be 60, 70, 80, 90, and then the 100. Okay, so the gap between one line and the next is 10 millilitres. So that's what 1 unit is here, 10 millilitres. So they're not always going to be 1 like we had in the last 2. All right, the limits of accuracy, we're doing the same thing, plus or minus 0.5 times the smallest unit is 10 millilitres. Okay, so now we're going to work out this bit here. 0.5 times 10 is 5. So our answer is plus or minus 5 millilitres. So you can imagine if you've got a measuring jug and you've filled it up to a certain level and you're trying to work out what the measurement is, if it's sort of very close to this line here, you would say, well, it's 50, 60, that's 70. Right, so if I blow that up, just so you understand what I'm talking about here, if I just make this bigger, so if I measure something and it happens to be here, I'd call it 70. If it happens to be here, I'd call it 80. Right, so you're going to what it's closest to. So for me to call something 70, it would be between 65 and 75. So if we were doing the upper and the lower limits, the upper limit for this measurement would be 75, the lower limit of the measurement would be 65, and we're calling it 70. Okay, so you're going 5 millilitres up or 5 millilitres down for your upper and lower measurements. So have a go at the ones in the homework. If there's any problems, please let me know.